trying to look for the text of the question. I mean, because the chat basically is not seen on my laptop. I have to open another laptop to look at the chat. Okay, so I think the question to Hitesh was that, do you include design or the time required for design or the activities required for design as part of your inner loop, and or whether it is counted for elsewhere? Hitesh, you are on mute, please.
Okay, yeah. In some sense, it is kind of included in the sense like when we signal back to the teams that, hey, the time between your work item into the active state and the commits that we are seeing is kind of large. So it's kind of a signal whether there hasn't been a proper planning or whether there hasn't been a proper kind of breaking down of work items into various phases, right? So that's kind of more like an indirect signal, right? We don't really track the amount of time you have spent in design, right? But to your second comment, which is like, when you actually give this feedback to the team, do you end up seeing them spending more time on the left-hand side in designing rather than actually on the right-hand side? We don't track that, but I think that's the stage where we want to actually go, right? In the sense like we want to shift as left as possible, because when you're on the left-hand side, right, you don't deal with tools, you don't deal with processes, right? You deal with basically mostly yourself and kind of maybe some of your team members while you are kind of in that designing phase. It's okay for us to kind of spend more time there. The problem is like as you go on to the right hand side, like and if you discover some issues over there, you end up paying a lot of tax because of the process overhead, because of the tools which are involved in this. So I would say like it's okay to spend more time on the left hand side, like even if it is kind of getting shifted on the left hand side, it's a desirable state for us in that sense.
Yeah, okay, thanks.
So Venkatesh, is this question for Hitesh?
Yeah. Hello, Hitesh.
Hey, Venki. Good to see you.
So I actually have a question that perhaps both of you could answer, perhaps taking turns. And I think in both the presentations, there was a lot of emphasis on processes. I mean, these are large processes you're talking about. So the question is, what is the role of human competencies? Where do they fit into your entire larger scheme of things? That's a question to both of you. How would you judge human competencies, and how would you account for, both their quality and their availability?
Are you gonna feel that first, Adi sir, or I can go whatever?
Yeah. See, these processes, if you look at it, I mean, of course, I didn't kind of, in my schematic, I didn't try to put in where human comes into the picture. But all of these are, I mean, in fact, probably every activity over there is an activity which cannot be completely automated. Okay, we would like to really, have an activity which is driven by humans. But then the objective, or at least my proposal, was that the inputs and outputs of all such activities are captured in a digitized form, and not just by digitized form. I don't mean in the form of a document or natural language, but a more formal representation which may have a notation which is consumable by humans who are not necessarily programmers. So for example, in the case of domain experts, they are not programmers. So we need to have a representation and notation, a notation which is consumable to them, but underlying is a formal representation, because that is what is going to enable processing by machines and being able to provide input to the users for the next steps. So I think in creating the digitized specifications, in converting the digitized specifications into code, at every stage there is human expertise which comes in right from the domain stage to the development stage. But what is machine enabling to do is to expedite all these activities by means of digitization, as much digitization as possible.
Cool.
Thanks. That's very good. Yeah.
To answer from the perspective of tooling and processes, right? I would say we basically take a stand which is, I would say, more kind of less judgmental about kind of engineers making mistake or humans basically being incompetent. We try to basically utilize the knowledge to improve the tools and processes as much as possible, right? Like how can we basically enable tools and processes so that they are more favorable to achieving you what you want to do eventually. In the process though, right, we have identified that, and again, this is all data driven. We've identified that when you talk to developers, right, there are some sort of cultural signals in the sense like, for example, if you see a lot of bugs which are caused because teams are not writing test cases, right? When you talk to developers, it might actually surface out that, hey, you know what? It's not really valued much when I work on engineering depth, but it is valued more when I work on features, right? So this level of conversation, basically, when it comes out, when you talk to people, it's enlightening in the sense like, you want to talk to basically everybody in the team collectively to ensure that like, they value certain things which are really important from engineering perspective, right? So the stand that we take is more collective, more holistic. Improve your culture, can we improve your processes and tools rather than a specific incompetent person maybe in the team.
Good, thanks.
Yeah, I kind of wanted to add a comment to it, if you don't mind, Hitesh and Hardy. So I guess it all depends essentially on the processes of the organizations itself, right? Every project you probably have to fine tune the processes and the people involved, etc. So in that sense, the boundary of the inner loop and outer loop is a bit hazy at times. So it probably only takes a lot of time for you to actually see similar process-oriented projects or projects which require similar processes, and then you start defining these boundaries, and that's when real productivity probably comes about. So until that point, it's kind of a back and forth cycle, So I guess that's probably the way to look at it.
I don't know if you have time to basically feel that, but I would really like to make a comment on that, right? So in the beginning of my presentation, right, I said that the Tools for Software Engineers group was renamed into One Engineering Systems, right? Because partly to say that, like, there are tons of processes and tons of tools at Microsoft, right? The whole idea of these One Engineering Systems is to actually, can we identify the common problems, right? For example, build, is one problem, which is like really common to all the big code bases, right? Testing, right, is one problem. Flaky test, these are another problems, right? Everybody has the same PR system to begin with, right? So long PR times, long PR reviewing times. So some of these are like fairly common, and they are probably a function of, I would say, product and team. In some sense, right? But then there are other categories which are like, very team specific, and I completely agree with you. Like, that's the place where we have to basically dive a little bit more deeper into understanding the problems, or maybe leave them like until they have problems.
All right, so we'll probably move on to Balwinder and come back to Venkatesh in a bit. So Balwinder, there were a lot of questions for you, from Raghavan and Shouvik. So I'll probably, have Raghavan directly address them to you, if you can, Raghavan.
Sure, I can ask it directly.
Yes.
So my question was, since there are only few limited number of quantum algorithms, how to develop general purpose software? So I thought, would general purpose software run on general purpose computing and then call quantum libraries which will run on quantum computers? Is that the model for writing general purpose software?
That is true. Because in a complex problem, there may be certain pieces for which you want to exploit the quantum systems there. So you got it right. So there is a specific, let's say, function that you want to run on a quantum hardware. So if you have an algorithm for that, you will be able to exploit that.
Okay, and thanks. And is there a follow-up question? Is there a set of applications or a set of domains where these quantum libraries are going to be more useful? Have people thought about this?
I have seen there are people who are trying to exploit quantum platforms for, let's say, certain kind of simulations. A lot of work in molecular chemistry, let's say, and cyber security. People are trying to develop things. So those are the areas where it appears that people are developing certain ready-made libraries, where a developer who wants to, let's say, do some kind of encryption of certain thing in a quick way, let's say, right? So instead of going with a classical platform, you want to exploit the available quantum library, which invokes the suitable operation on a quantum platform. So as I said in the talk also, so as of today, to us at least, it appears that this is a very specialized area, and you do not have many applications there. Did that answer? Or?
Yeah, thank you.
So I think a related question comes from Shovik in terms of how successful Q Sharp from Microsoft has been. I guess.
See, we didn't develop a very complex software on it, to be honest. So what we were trying to evaluate is more from a programmer's perspective. See, a little bit of a history of this. I was teaching programming paradigms a couple of semesters back, and then some students came up with the quantum programming questions. I was sort of new to this whole domain. So that is when we started exploring this. I'm talking of 2018 actually. So at that time we installed all the available toolkits that are there. So we started with IBM Quantum Experience. We looked at Microsoft's Q Sharp. Right, at that time it wasn't really that good, to be honest. But now they have improved. I think the IDE is relatively better integrated with Visual Studio Code. We use that one. So today they have sort of smoothed the rough edges. So that's what I can say right now.
Okay, so we'll probably come back when we have time. Maybe there are a couple more questions for you, Balwinder. But yeah, I just wanted to ask Venkatesh a question in terms of the idea of creating such a language. Where do you see the most common use cases for such type of languages?
Okay, a lot of the current research in this area is targeting intermediate representations for compilers.
So it's primarily in terms of being able to automate proofs that you want to have a request.
So there are two kind of driving forces, if you will. One is making sure that your code intermediate transformations are all correct. So you want to be able to have languages which are amenable to reasoning, and naturally the types naturally come in there. Okay. The second thing, of course, is hopefully that these programs, if you move them to the higher level, you actually have type programming languages, which, for example, functional languages that typically give you higher order functions and so on, as something sort of alien to C programming and C++. So you want to move to a paradigm where Balwinder was just talking about programming paradigms. So you want a paradigm of programming with loops, but at a higher kind of higher order way. So I can see both from the high level perspective of high level programming languages and also compilers. So that's where most of the interest is. I'm sure there's also some interest from the architecture people, because after all, these arrays and so on are mapped, the memory models and so on. So there's interest at that level as well. I don't know much about the architecture level.
Yeah, so if I may just add to this thing. So all these quantum gates, for example, since Venkatesh was talking of tensors and arithmetic around it, so in my view, there may be applications, a good deal of applications in that space.
Right. So right now the applications are kind of driven by machine learning and so on. So heavy use of tensors and so on. So that's currently the big driving force, data intensive applications. That's kind of always been the scientific computing has always led the demand for better and better compilers. But I think what is happening in the recent times is both the kind of amalgamation, if you will, or confluence of programming language type systems and proof techniques and automated proof techniques with more classical compilers for arrays and so on.
Okay. Thank you, Venkatesh. So I guess talking about transformations, maybe that's like what RD's been doing now for 25 years, I guess, isn't it? From retargetable compilers all the way now, he's still pitching for transformations. So there are a couple of...
That's the way you understand a process by what it transforms to.
Right. So not
going away. Yeah.
Sorry?
I agree with RD that they're not going away.
Yeah, they're not going away. I think that the other side of it is they're getting far too domain specific.
Yeah.
Well, I suppose so. Yeah.
So there are a couple of questions from Raghavan again. This is to RD. So Raghavan, if you can go ahead. Raghavan? Okay. So maybe I'll just read the questions, So the question says, is your proposed architecture suitable only for transformation, or is it the right architecture even for new software development for business applications?
That's an interesting and good question. Yes, that is how we would want to look at development itself. So if the development of specifically platforms, and in fact, we see that happening more and more, I'm talking of the software being produced for enterprises, business enterprises. Most of these softwares are, they're having a platform flavor, primarily because they want to be able to support variations of the products and services that the enterprise wants to provide to its customers or consumers, and therefore the capture of domain knowledge or the capture of the variations in the products and services that the enterprise wants to offer is one of the primary driving factors. And therefore, the answer to the question is yes, it is an important aspect that we would want to see going forward to be becoming the critical part that drives the
Okay, looks like just got cut off.
Development processes. Sorry, I got disconnected for a while.
Yeah, please go ahead.
Yeah, so I think the answer to Raghavan's question is that yes, eventually we would want to see that this becomes a critical part of the development development processes itself, the domain knowledge becoming the central piece for driving what is the eventual software system should look like for an enterprise.
Thank you, Arti. There's another question again from Raghavan. So are there technology frameworks available today to express all business terms, rules, processes, and workflows digitally, and then link these to low-level code whenever necessary?
There are tools available. How good these tools are is if that's what is the question, then yes, I think they need a lot more improvement in terms of not only capturing this domain knowledge, but also being able to provide the traceability which Raghavan is referring to, but also all kinds of verifications that we could do in the specifications itself or in the models itself. So traceability being one of them to the low-level code. There are very what I would call domain-specific and tool-specific solutions that are available from process model descriptions as well as from rule descriptions to code. But all of these are very, very specific solutions. They are not general purpose yet, to the best of my knowledge.
I had one more question if there is time.
Yeah, go ahead.
So RD, can these business terms, rules, processes, and workflows can they be made executable along with some linked low-level code? So is this, I mean, are you proposing this as a way of software development, or is it only a documentation? This digital
Yeah. So Raghavan, I think the whole idea is to make it executable. Now the point is that there are so in fact, if you look at the verification and validation methods, which at least we are trying to build for this kind of representation, for the representation of the domain knowledge, do need interpretation of the rules. So we need to evaluate really the rules at the interpretation time or at the verification and validation time. So these rules are need to be executable. But can we, sort of simulate or execute all the rules? Now, at least in the examples that we have tried out, we are having difficulties in interpreting all the rules that capture the organization. There are some rules which depend actually on the data, and for that we will have to move over to a more simulation kind of model where we'll have to create synthetic data and then be able to simulate. So I would say a general answer to your question is that yes, the idea is to move towards more interpretable or simulatable specifications, definitely not just as a documentation.
Okay.
Thank you. So if there are any questions from the audience, please, if you can put up your hand and feel free to ask to any of the panelists here. Yes, Venkatesh, please go ahead.
Yeah, the question to RD, there's a lot of talk about these days about this thing called digital twin. Okay? And the idea is it's kind of related to what Raghavan was asking. Are there executable interpreters, for better word, that simulate an organization? And these, so in other words, are there digital twins for organizations and their processes?
Yeah. So okay. Now, yes, there are digital twins being talked about. In fact, the Software Systems and Services group within TCS works heavily on these. They are working on, in fact, digital twins not only for supply chains but also for thermal power plants and for a few other types of organizations, because the research really looks at the types of organizations, and then it is really the business unit which takes up and then tries to implement for the various types of organizations that they have for a particular domain. Now, I see a little bit of difference between what we are trying to propose over here versus the digital twins, and this difference comes more from what we are trying to do is to capture what I would call the business knowledge of the enterprise. In the case of digital twins, we are also looking at a lot of the environmental aspects, a lot of all the aspects that come from the environment, and also from the dependencies of the enterprise on various other enterprises as well. Okay, so the digital twin, in my opinion, or as I understand it, is trying to capture a lot of dynamic aspects of the enterprises, which at this point in time, at least I don't have enough information about that, whether we should be able to capture it within the domain models that we are talking about. But we would like to see, eventually we would like to see in some sense a marriage of the two, because the digital twins are really talking more about the overall processes, while we are talking more about the core businesses of the enterprises.
Okay, we do have one more hand. Nandakumar, please go ahead. I think you need to unmute yourself.
These are general comments I wanted to make. These are not related to whatever has been spoken by the speakers. If I am allowed to talk on that, I will talk.
Yeah, please go ahead.
Okay, these are two things I want to tell. One is related to the licensing model of software rather than one-time purchase, and rather than, I wanted to suggest a pay-per-use model will be more appropriate, is what I wanted to suggest. We have a lot of facilities, features in the software bouquet that is provided by major software providers. If pay-per-use model, if it is provided to users, that will be a welcome change in my opinion. That is one thing. Second thing, I wanted to say about this. Users are given no option when accepting this licensing policy of a software. There is no option. You have to accept, otherwise you don't use the software. There is no option. There should be a free form suggestion to be given to the user. What specific thing he is not liking in that? That free form feedback should always be there for any feedback whenever you get feedback from the users. These are the two comments I wanted to make.
Sure. Thank you. I'm sure people from industry will be listening. To the first question, I guess, with the 5G coming up, that much of flexibility will be built in terms of pay-per-use. I mean, we are already looking into it. I mean, I have personally seen Netflix, which is exploring the option of not just even the movie as a whole, but maybe exploring 10-minute clips if they want to look at it and only pay for the 10 minutes, etc., etc. These are some things that are explored. Maybe that is something that can come into the software industry also. But bandwidth and technology should support it, obviously. Anyway, moving on to the actual, wrap up itself. So we are on Q 145, so we should probably start wrapping up. So I want to thank all the speakers first, because these are very, very open-ended topics, and I'm sure if students are interested, please contact them. There are plenty of research opportunities that exist in this space. Software engineering is a very, very vast space. So vast number of topics that exist. So on those lines, I would really want whoever is online right now, if possible, just switch on your videos for just about 10-15 seconds. If possible, I just want to make a, quick snapshot. So log in for just about 10-15 seconds, everybody, whoever is online. I would like to see at least about 20-30s over there. Yeah, thank you, please. More. Lalit, Raghav, all of you also, please. Just for about next 10-15 seconds.
So don't forget to say cheese.
Yeah, I'll probably say 3, 2, 1, right?
Okay.
Whoever else, others, please kindly log in and open your video camera for just 30 seconds or so. We should be okay with the bandwidth for 30 seconds. If you want to do some touch up, that's okay.